How is he serious?
Here we go. We'll show you how to graph a line when it's in gradient-intercept form. And what's gradient-intercept form? It's when the equation is written like this with y by itself. And we have to remember two things with gradient-intercept form. One is that the number in front of the x is the gradient, and we'll talk about that a little more. Also, we got to remember that that guy is going to be the y-intercept. So we've got two things we need to remember, the gradient and the y-intercept, and that's all I need to graph a straight line. So how do I do it? So first step we're going to do here is we're going to define our gradient and y-intercept from the equation. All right, we look at the equation and we say, okay, what's the gradient, what's the y-intercept, and it might help to write that down. When we're dealing with the gradient, also remember that the gradient is the rise over run. So if we can't express that gradient as a fraction, which we will be able to in these examples, that'll help us. Okay? So after we define that gradient y-intercept, we're going to plot the y-intercept first, and what that y-intercept is, it's the point on the y-axis. Now, the third step is we're going to use that gradient that we figured it out before to plot the second point from the y-intercept. Okay? So that second point we plot is from the first point we plotted, not from 0 or anything. The first point we plot is the y-intercept, and the second point we plot is going to be from that y-intercept. And the fourth step is to, once we have those 2 points define a line, so we rule the line. Okay, let's look at our first example here. Okay, first example. So let's go through the steps. Define our gradient and y-intercept. Gradient is 1/2, and y-intercept is -2. Okay, so start with the y-intercept. That's the point on the y-axis. That's -2. That's right there. And how you use the gradient to get to that second point is, our notes from last lesson is, remember, the rise over run is our gradient. The top number tells you if you go up or down. The bottom number always run to the right. So gradient of 1/2 means we go up 1 to the right 2, up 1 to the right 2, and that tells what our second point is. Okay? And I can keep doing that. Up 1, right 2, up 1, right 2. That's a gradient of 1/2. Rule the line and draw it. And make sure your line goes through the whole graph and doesn't just stop at the points that you plot. Okay? Let's try another example. Oh, okay. Next example here, we'll look at y equals -2x plus 3. First up, define the gradient. Okay, the gradient is -2, and define the y-intercept. That's 3. When I do that gradient, I want to, remember it's rise over run, so I do want that gradient expressed as a fraction. So just put it over 1. There. So this gradient tells me that I'm going down 2 and over 1. Down 2 and to the right 1. So let's plot that on the graph and see how it looks. So the y-intercept goes first. That's where it crosses the y-axis. That's at 3. That's right there. And the next step is to, from that point, use the gradient to plot the second point. And that gradient of -2, 1 tells me I go down 2 over 1. And if you want to be more accurate with your line, keep doing that. Keep going down 2 over 1, down 2, I should say down 2, right 1, until we get our straight line. All of those points should be in a line. If they're not, then we're doing something wrong. And then we carefully rule them up. And we don't do connect the dots. We go all the way through the graph. And we have our line right there. That's got a negative gradient, so it's going down as we go to the right. This guy had a positive gradient, so it's going up as we go to the right. Okay, next example is just when there's no constant term at the end. So that means I've got my gradient is 3/4 and my y-intercept is nothing, which means my y-intercept is 0. So write it down so we don't forget. Okay, so the y-intercept starts at 0, and then I'll use that gradient to get the second point. Okay, so from the y-intercept, gradient of 3/4 means I'm going to go up 3 and over 4. Up 3 over 4. And now I draw the line. Okay, let's look at an example where it looks like there's no gradient, but there really is. This one right here, first thing, define your gradient and your y-intercept. If there's no coefficient in front of that x, there is. It's just an invisible 1. Okay, so we got my gradient is -1, and I want to write that as a fraction, so just put it over 1. And I got my y-intercept is +1 right here. So start with the y-intercept. That's 1. And my gradient won't tell me anything unless I have it written as a fraction. And a gradient of -1 over 1 means I go down 1 over 1. Down 1 over 1. And I can plot those points. It's a linear pattern, so I can just keep going there. And then I can rule the line. All right. My last example is when the gradient just looks kind of slightly different, in that it's not a fraction or an integer. So what I do is if I've got, okay, my gradient is 0.8, but I don't want 0.8 because I want that rise over run thing. So I can change a decimal to a fraction. 0.8 is 8/10, and 8/10 simplifies to 4/5. That's what I want, not 0.8. 0.8 tells me nothing. 4/5 tells me the rise over the run. And my y-intercept is -4. Now I'm ready to go. Starting with the y-intercept at -4, which is right here, and moving up 4 and to the right 5. So up 4 and to the right 5 would be right there. Okay, that's up 4, right 5. Rule it and draw it. Okay, so that'll get us started today. And all of these examples are ones that are already written in gradient-intercept form. So it's not too difficult to get the gradient and the intercept. If there's no constant term, then the intercept is 0. And if it's just an integer, we put that integer over 1 to get the rise over run. Okay? Oh, good luck.